protection in this series of Belt and Road webinars. As you know, I represent Odessa National Maritime University in Ukraine, in Odessa city. I'm a professor of this university, and also I'm head of Department of Sea, River, Ports, and Waterways. As part of introduction, I can say that during last decades, a new interesting piling technology was developed by company Giken in Japan. In 1975, the world's first reaction-based hydraulic pile jacking machine called silent piler was invented. As piling works were considered the primary cause of the social problem, noise and vibration-free piling machine was a solution to the severe construction pollution. This determination brought innovation and change to the piling industry, creating the pressing industry. Since 2007, a lot of researches devoted to the pressing technology were conducted not only by a Giken company, but also by International Press-In Association. Some achieved results of these developments are described in this lecture. We will consider the following items: the silent piler, the piling ring, some principles of the pressing method, applicable piles and penetration techniques, Giken implant foundations, Giken reaction-based system, and some case studies. So, this is a general view to the works produced by this pressing system, and this is typical plant layout of the piling machine, which can press piles into soil. This is obviously power unit and some auxiliary equipment such as crane and so on. The principles are demonstrated on these slides. The machine use previously pressed piles as reaction piles and press the new pile for interlock of the previous pile. The difference between these methods is demonstrated here. You see the glass with water is not disturbed in comparison with use of percussion method, which is characterized by noise and vibration. Also, we may consider pressing method with vibratory method. Also, water is not disturbed, and please compare with driving by vibrohammer. All is vibrating. So you see some pictures from construction site where these piler machine are in use. You see this sheet pile driving, but not only sheet piles may be driven, but also tubular piles and some other types of the piles, which we will see later. Applicable piles for this method are as presented here. You may see U-shaped sheet piles of this shapes and these dimensions, that sheet pile of these shapes and these dimensions, tubular piles, diameter from half meter to 2.5 meter, so very large diameter tubular piles may be driven, and so-called combi gyro wall, combination of piles and sheet piles for very rigid retaining structures. Maximum moment of inertia is rather large. You can see these figures. And regarding soils and related approaches, we may see this illustration. For soft soil, we may apply standard press-in when piler is pressing in sheet piles or tubular piles. In case of dense or stiff soils, we recommend press-in with water jetting in order to simplify the pile penetration. And for hard soil condition, supercrust system with augering may be applied in order to crash this hard soil and to provide necessary depth of driving. For very hard conditions, and in case of application of tubular piles, a technology based on gyro press method or rotary jack-in may be applied. This is a combination of rotating of the pile and pressing into the soil. Let us consider all these approaches. Standard method. You see that sheet piles are driven using interlocks to construct a solid wall. Using the previously driven piles as reaction stand. The next is use of water jetting in case of not soft soil. So it simplifies the pile driving method. In order to reduce soil resistance. And in case of hard soil, augering is applied in order to crash the hard soil or boulders or gravel. So in any case, we may provide pile driving. There are different modifications of such method, depending on soil and pile. Gyro press method, combination of rotation with pressing. In this case, we have not solid wall, but the piles with some spacing. Comparison of pile driving depths and maximum N value in CPT method. You see, the first zone is zone for application of the standard mode, when N value is up to 20 and the pile driving depth is up to 20 meters. Next zone is zone for application of water jetting mode, when N value of the CPT method is up to 50, with maximum piling driving depth 20 meters. And the third zone is super crush mode, applicable to very hard soil conditions such as cobbles, boulders, butt obstruction, rock, etc. N value may be more than 50 and also larger pile penetration depths. Here we see the sphere of application for single pile driving with standard mode and water jetting mode, and also zone of application for double pile driving, also for standard mode and for water jetting mode. All other zones are zones of application of super crush method, both for single and for double pile. And here we may see penetration methods or penetration technology for tubular pile application, also regarding N value of the CPT method and pile driving depths. So for tubular pile, we may apply standard mode for N value up to 15. For water jetting mode, we may apply for soils with N value up to 50 and pile depth up to 30 meters. And all other, in yellow, we may use super crush mode or gyro press mode, and it may be in use for very hard soil conditions, some butt obstructions, rocks, cobbles, boulders, and so on. This is a sample of damage of conventional gravity foundation after some actions such as earthquake in northeast Japan in 2011. The breakwater was ruined by this earthquake and by following tsunami. So it was a gravity foundation. It was constructed as embankment, placed on the sand layer, and covered by concrete elements. Unfortunately, this structure was not reliable. Such structures may be reconstructed by Giken implant foundations using, as you can see, these pressing technology, when piles are pressed or pressed with rotation through existing structures without disassembling existing structures. So this definition, Giken implant foundation, may be explained as embedded pile foundation anchored into ground by pressing method. So you see, such medicine term implant may be used also to describe engineering process. Let us consider some content of this Giken implant foundation. The first series of structures may be characterized as Giken walls, another as Giken foundations. Giken walls may be produced as steel sheet pile wall or steel tubular pile wall, clutched, or tubular pile wall, unclutched. And finally, there may be combi gyro wall. As to Giken foundation, usually tubular king pile foundation is in use. Let us consider some of these structures more detailed. Clutched steel tubular pile wall. So interlocks are used between tubular piles. Dimensions are demonstrated on this slide, and maybe different interlock connections applied to connect piles in this solid wall. In case of necessity, water tightening system or grouting system may be applied in order to provide required permeability. This water tightening system may be provided by geotextile or some another materials placed in this clutch. And achievable permeability may be expressed by these figures. And this is a sample of implementation of this approach when the Crossrail project was implemented in London. The cofferdam formed with 303 steel tubular piles enabled to construct the station box of Isle of Dock Station in the canal of Canary Wharf. Also, you see the interval of dimensions for application of steel tubular piles with such interval of spacing between these piles. This is the fragment of construction process. You see that both railway and road for machines are not closed. All these construction works may be produced without stopping of the traffic. And this is interesting illustration that rotating with pressing may be applied to press piles through existing concrete or reinforced concrete or stone structures. Also, some samples left picture demonstrate strengthening or reconstruction of the bridge. On the right, we see the damaging of the existing structure by rotating with pressing of the new piles. So this technique provides possibility to drive piles not only into soil, but also through concrete or reinforced concrete elements of old structures. It's not necessary to deassemble existing structures and to replace them. Watertighting system for steel tubular pile wall. They consist of closure piles and grouting. So you see this connection between piles. So water cannot go through this solid wall. Achievable permeability is rather good. So is one of possible options of grouting, connection between piles in these interlocks. Steel tubular pile wall. This is example of construction of the cofferdam in Japan. Using this water retention of about 7 meters height. And very interesting system named Combi-Gira wall, which consists of sheet pile wall, which is strengthened by these tubular piles. Primary elements are tubular piles and secondary elements are sheet pile. Dimensions are demonstrated here. Piles are welded to the sheet piles by in these points. This is a sample of the process of creating Combi-Gira wall when we can apply both sheet piles and tubular piles. Chuck is changed, and after sheet piles, the tubular piles may be pressed with rotation. Road retaining wall, you see the underpass retaining wall produced by combi giro wall when these structures are combined using this approach. And different configuration may be applied. You see the configuration A when king piles are located at the passive side of this solid combi giro wall. But also there may be another configuration named configuration B, when sheet piles are located at the passive side of this combi giro wall. So in case of necessity, we may change position of piles regarding passive or active side of the ground pressure. King pile foundation using tubular piles. You see that it's possible to drive a piles with large spacing between them. Spacing maybe 2.5 diameters of the tubular pile. And in the picture, we see the sample of construction of the breakwater using such construction, design and construction approach. This is demonstrating of rotating with pressing, using a special additional equipment to enlarge spacing between piles. So-called pile follower. Mainly hydraulic connection is used for such operations. And also machine as usual is self-moving due to this technique. In which structures we may apply such construction method? You see the backfill retaining wall made of king steel tubular piles of diameter, of large diameter, and the backfill, again, the wall, upper wall may be reinforced concrete or concrete, but main loading is applied to this tubular pile wall. This is also illustration to such kind of the structure. You see backfill behind the concrete wall, and foundation is provided by steel tubular piles. This is a sample of constructions of so-called Giken barrier if we have to defend some important structures. Barrier is made of precast concrete soaked at top of the tubular king pile foundation. Details are presented here. Some properties related to this kind of the wall You see the wall thickness in the horizontal axis and rigidity on the vertical axis. And different type of the wall, different types of the wall are compared here. Second pile wall, contiguous wall, combi-gyro wall composite, tubular pile wall, diaphragm wall, and tubular pile wall composite. So you see that the largest values of the rigidity is provided by tubular pile wall with composite. So with filling of the tubular piles with concrete. The second place is for diaphragm wall. The third place for tubular pile wall without composite. Another conventional types of the walls provide smaller values of the rigidity. Also, let us compare bending stiffness and cost index. You see that the same types of the wall are compared, and the best parameters are provided by tubular pile wall. If to compare provided bending stiffness and cost index. This is a picture illustrating so-called GRB system or geek and reaction based system. All necessary equipment is located only on the tops of the piles. Piling machine, which is driving a pile, power unit, clamp crane, and pile runner, all these machines and equipment is moving along the piles. So it's not necessary to apply additional platforms or additional barges if it's work on the water and so on. This is illustration to this GRB system. And option to work in water, in the sea. All is moving regarding the speed of construction. Next illustration, GRB system for tubular pile retaining wall. Large diameter of tubular piles up to 1,500 millimeter diameter. And you see this GRB system in work. Some case studies. This sample relates to New York City, Long Island Express and Cross Island Parkway construction, where a road retaining wall was designed and constructed using pressing method. Another case study relates to London, construction of BBC Broadcasting House, where tubular piling works were produced in commercial area. Another case in Japan, Hodogaya bypass. The project related to road widening. Due to heavy daily traffic, it was necessary to widen the road. There were two sloping embankments on both sides of the road. And the peculiarity was also that in the vicinity of the road was a very dense residential area. So pressing method was applied in order to provide construction without stopping the traffic. So you may compare conventional method, the right side, when a special platform has to be constructed to be used in this construction process, and application of pressing method. So the difference is obvious. So you see also here the construction works on both sides of this bypass. Also, fragment of the construction works. And after widening. Another case study relates to river improvement works. It was produced in Kandagawa River in Japan. So also we may compare application of pressing method. You see these machines on both sides of the river, and application of conventional method when it was necessary to construct a special platform to cover all this river. And results of the work after completion on the left side of this slide. I would like to express some gratitude to company GIKEN and also to International Pressing Association for these interesting materials which were provided for my presentation. So thank you very much for your attention.
Yeah, thank you, Professor Michael. Now, if any questions? Anybody?
So, can I give questions? It's
Yes,
Professor
Professor.
Askar from Kazakhstan.
Sure.
So, thank you very much, Professor Michael, for your very interesting lecture, especially for preparation of